I am Jonghwan Lee, Assistant Professor of Engineering and Brain Science. I work in the School of Engineering and Carney Institute for Brain Science. This is Faces of Brown Research. What we eventually want to see, what the future we envision here is let's say you visit your primary care physician every year, right? So when someone visits primary care physician, can have an annual visit, we want to add simple eye scan as a kind of annual eye exam. It's very simple. You don't need dilate pupil, and you can just put the machine and then scan your eye. And we want to develop AI, which analyze your eye image and other data like blood pressure, heart rate, and blood test, and other like a BMI. And then AI can tell you can after every annual visit, you can receive a report from AI saying that, hey, you have, for instance, 40% of probability of developing some Alzheimer's disease in 5 years. So that if you get this kind of report every year, and if the number goes up and down, you can ignore stupid AI. But if the number consistently goes up year by year, then you can take it seriously. So that the AI will suggest you, okay, your number goes up, and which is not good. So that we suggest you taking brain scan or lumbar puncture, like a more invasive and expensive early diagnosis. So this is the kind of annual eye exam, and AI will predict your risk of having disease several years in advance, so that you can have a chance to take the brain scan not too late, so that you can have time for many beneficial activity like a lifestyle change, or you can try to sleep better, eat better. And also there are many kind of early intervention available, so you can try to take it, consider it, and also you can plan how you will prepare when you have your brain disease start. So that's our goal. And for this, we need a lot of things. First, we need to know how we need to know how the brain change before the disease start. So we need a very long-term trace of how many things change in the brain, including blood vessels and the blood cells called neurons, and many other things. So we want to measure how this gradually change with the aging. In the ideal world in humans, but it will take 20, 30 years, right? So it's almost impossible. So what we started is we started with the animal models of this disease. So we put the animal, and then we use the very amazing 3-dimensional microscope to measure many things from the animal brain for a long time. That's the published study. Our population is getting older and older, and all these kind of degenerative disease is becoming a big part, not only for families and cares, but also the government and healthcare system. So for instance, Alzheimer's disease alone is expected to consume $600 billion of Medicare and Medicaid budget every year. And $600 billion is the half of current total budget of Medicare and Medicaid. So some people say that makes no sense. It's economically not sustainable, right? If we have to use the half of the total Medicare and Medicaid to single disease, that's not good. So and that trend is really skyrocketing because our population structure is getting older and older. So we believe the suppressing this kind of disease prevalence is not only important for this economic reason, but also important for many people's quality of life at the later age. And there are a lot of burden on families for caring of this type of neurodegenerative diseases. It's very different from cancer. So our goal as a team of AI engineer and imaging expert is as I mentioned, we want to develop this very early screening tool, kind of warning system, alert system, so that who need to go to get a brain scan, who need to go to the lumbar puncture test, such like that early enough, so that we can change the trajectory of this societal burden and individual kind of risk. So that's I believe why this research is so important. Yeah, so within the bigger picture, I mean, to get that AI available in the real world, we have a lot of steps to do. And as I said, this neurodegenerative disease is very unique because it develops very slowly over a long time. So it's very challenging to study. And even in the animal model, if you want to trace how something gets worse and worse in the brain for a long time with aging, we have to take the image of the animal brain over and over again for a long time, up to 1 year. So that was challenging so far. And I believe no one has shown it is technically possible, even in the animal brain. So the published data was focusing on demonstrating, okay, this is possible, technically possible, and how we will analyze this huge data set for a long time. So next step is naturally, okay, we have this technique, and now we want to look into the brain of specific disease, like Alzheimer's disease. So we do have very specific animal model for the Alzheimer's disease, clinically relevant model called APOE4, and we are tracing how the gene of APOE4 lead to slow change in the brain in the animal model for a long time using this technique. That's our next study, and we completed data collection, and now we are analyzing data, and we will soon publish a paper. And the next step we are trying to start is the human study. So we wanna our basic idea was we wanna do eye scan and to predict what is happening in your brain a few years later, right, from the eye scan. So that's the ambitious goal of prediction. And for that, we need human data. We take the eye scan, and then a few years later, we need to take a brain scan, so that we can correlate and we can train the AI, so that our AI can predict what will be happening in your brain a few years later from the current eye imaging, right, retina imaging. So to do that, we need a lot of data, and we need a lot of collaboration with the hospitals to recruit people both from general population and early stage of disease, and take all these eye scan and brain. It's a huge, complicated project. The project we are initiating is quite unique because it is not a clinical trial alone. We need not only reach out to the patient in the clinics who already have some early stage of Alzheimer's disease, but also we need to reach out to general population community for recruiting kind of healthy patient, healthy subjects, right? So that we can trace who will develop some bad proteins of the brain in 5 years and who will not. But fortunately, we have some genetic part, so that we can predict not accurately. It's a very complicated disease, but at least we can see, okay, when we recruit healthy young people like you with some specific gene, having some specific gene, then it's worth trying track you like for many years, and we can take eye scan every year. At the end, we can scan your brain and see how it goes. That data will be very helpful to train our AI. But currently, we are proposing 5-year study. So we recruit a lot of subjects, both healthy and it's early stage of the disease. And then we will trace them using eye scan and brain scan for 5 years. And we will, at the end of this project, we will train the AI and see 5-year data are enough or not. Then we will have a chance to make a much more informed decision about whether or not we will need another 5 years. But currently we are planning 5-year study, and once AI is shown to be promising, at least not kind of validating everything, but once our approach is shown promising out of this 5-year project, we believe we will have a lot of chances to continue to extend this AI development up to the point where we can disseminate and then commercialize this approach to the public. So 5 years at least, most likely or even more. Our team is serious about ethical part of this study. So as you can imagine, we are proposing to recruit general population and doing some genotyping and select who will be participating in this study. And all this kind of genetic testing and counseling is very carefully designed, should be very carefully designed in the ethical point of view. So we do have experts on that in our team. So we will approach very carefully to the study design and exclusion of the study. And we have an advisory board for all these human study regulation and compliance and research integrity and ethical review. So we will thoroughly develop the protocol and study design. We are very serious about ethical point of view, and also the current project is kind of aiming to make a real world impact. We really want to see the current healthcare routine, like annual visit to primary care physician, for instance. We want to change a little bit about that. We want to add really eye scan, or many people go to local eye clinics to get eye scan and then get some AI report. But we know it's not easy. It's really hard to change. So our advisory board also includes some expert from business side and more like how we will, after this is the scientifically and technically proved, how we will develop this further for broader adoption to the public, and what is the best way to deliver this to the healthcare routine and public market. So that's the another part we are initially working on. It may be too early, but we are from the early stage of this project. We are keeping it in our mind to make it successful, not only scientifically and technically, but also in a business wide and commercialization. Yeah.